Hello everyone, my name is Omkar Swami and today I'm here with my new project, Nous. In this video, I'll be covering the overview, the demonstration, and steps to install my project on your computer and use it right away. Let's talk about Nous. Let's give an overview about it. Think of Nous as a smart remote control tool for computers which is powered by AI. Normally, if you want to manage a computer from far away, that is in a network, if you want to manage a bunch of computers, you will need to write some really long scripts and commands. Or else you can use tools like Ansible and so, but those tools also need a lot of scripting in it and there is a bit of learning curve there. So my project, like it totally removes that stuff. You just have to type a simple normal sentence in English and it will take care of everything else. This is the one of the initial versions, version 3. I'll be updating it and I'll give constant updates about it on my LinkedIn now. So here's how it works. You give now a simple prompt like tell me the IP address of the computer, and behind the scenes it will figure out the exact technical command that you need to know the IP address of any computer in Windows. Currently it is configured for only Windows machine. In coming versions I'll be pivoting to Linux as well. It is already a cross-platform tool, like it has potential to be a cross-platform tool. Anyways, so coming back to the working part, after making that technical command, it sends it securely to the all the computers that you want it to send, and then it brings the result back to you. And it does not stop there. The thing is, it does not stop there. It will give you the output in a formatted way, because usually the command line output is often messy, and for new system admins or those who do not have much experience being a system admin, they do not understand it. So with my explainer thing, the AI explains the output command to you in a simple and a normal and a clean language. So it is also built with a lot of security in mind. Each computer gets a unique ID, that is the hash code, instead of exposing its own IP addresses, which makes the system much safer and private. And along with that, as you can see the timer here, which is being displayed on the screen. This timer is a timer. When this timer reaches 00, all the hash codes are resetted, and the new hash codes are visible on the listener PC. So this maintains the obscurity in the whole system. And yeah, so in short, NOS is a simple remote system administration tool, which is secure, which is smart, and it you can use it even if you don't know much about technical commands. You can use it even if you are not a system admin yourself. So now talking about the technical terms, the tool generates the command using NLP, and there are two types of PCs in the whole system, like the whole platform. First is host. The screen that you are seeing, the NOS main NOS application is installed on the NOS on the host, and multiple client PCs have listener program installed on them. Listener does nothing but receives the command, runs the command, sends the output back. While all the technical stuff, the computational heavy stuff is being handled by the host PC. So listener can be a lightweight tool which you can install even on the low-end PCs in your organization. Now, the next thing, I'll start with the demonstration already. So initially, as you can see here, you have to start the server. This command line interface, this will be in background in future versions. In this version, I just kept it here just to debug and stuff. Now coming to this is the virtual box. I've used virtual box to demonstrate a listener in the network. So after opening the server, I'll open the listener. When I open the listener, an HTTP call is being made. Initially, it will relaunch itself as admin because this is the version of IP hyper listener that I have made for myself. So when you launch listener, initially it sends the HTTP call to the server and it registers its IP to that server. That server generates the hash code and it sends the hash code back to the listener PC. So instead of sharing the IP address, we are sharing the hash code, which ensures the safety. The initial call is an HTTP call. Later, whatever the communication is being made, it is done through socket programming, which is encrypted with TLS by using RSA keys. So let us copy this hash code and let's go to access gate. This is the main interface where you enter the hash code and the prompt and generate the command and send the command. Now, starting with the simple commands, let us ask about the IP address which I gave an example of. Tell me my IP address. Generate. When I click generate backend, there are two Python files which are handling it. First is backend.py, second is sanitizer.py. Backend.py is a Python file that receives the prompt and it generates the command needed. And later sanitizer.py is another Python file which receives the generated command and decides if it is malicious or not. If it is malicious, it won't send the command, but if it is not, it will. In our case, this is a safe command ipconfig. So now I'll send it. When I click send, the command is being sent on the virtual box. As you can see here, received command ipconfig and send the output. And here in the access gate, we can see, okay, here are the network configuration information that I have found for your Ethernet and Ethernet 2 adapters. There are two adapters running on my virtual machine. Now, let's have another example. What is username of my PC? Generate CMD. For username, you can use one or echo username. My username is Filakas of my host PC. And now let us see what is username of my virtual box. Okay, your username is Swami. So it is telling me that the username of this virtual box is Swami, which is actually correct. Now coming to the next command, I'll tell it to check my internet connectivity. Check the internet connectivity. Generate. For checking the internet connectivity, it will be generating a ping command and send 888. That is the IP address of Google server. So it will ping that IP address and it will ensure that the internet is working. Now ping command, this command does take time because it is actually pinging and it does send 4 or 5 packets, which takes some time. That's why it took time to receive the output here. Okay, so basically this is telling me that internet is working. Now coming to the next command, let us try with some malicious commands like yeah, turn off my firewall, generate. Now this is a malicious command can be generated here, that is of turning off the firewall. So now let us check what we can see here. As you can see, echo malicious command detected, not running the command. This command has been generated with this prompt. So the backend, it actually understood that it was an malicious command. That's why it told me that it is a malicious command and I'm not running the command. And even if like just to counter the error, if some guy who does not even understand this thing just hit send here, so this command echo this thing will be sent. I mean, after all, it is just printing this. It looks like the command that you tried was flagged as malicious and therefore not executed. After this, I've tried running another malicious command of shutting down. So as you can see, it is saying again saying the same thing, that malicious command is generated and it is not running the command. Even after sending, it says that the command that you have tried to run was flagged as malicious and therefore not executed. Now coming to the main workflow of my project. Initially, you need to install the listener on the client PCs. Multiple listeners can be used for adding other hash codes, except the current UI. This UI is for single hash code. You can press plus or minus. Here you can enter more hash codes and you can broadcast it to those PCs, and their outputs will be viewed this way, like the initial first hash code here, second year, fourth year. Well, I don't have another virtual box to demonstrate that currently, but you can do it yourself when you install Nous on your PC and you start using it. So when you open Nous on your host, you need to start the HTTP server. The You need to start the HTTP server by clicking on Start Server, and on the other side, you have to start the listener. The listener will make an HTTP call to register its IP, and the host will receive the IP. After receiving the IP, it will generate a hash, which is a function of time. So every hour, a unique hash will be generated, maintaining the obscurity. Like the timer is already present here. This timer, that the one which I was talking about initially. Later, this IP and hash pair, it will be stored in an SQL database. The hash will be displayed on the listener side, and when you open the access gate, you have to enter the hash and prompt. This is the access gate. You have to enter the hash and the prompt that you need to. Later, the command generation is done using RAG database. So I've used Gemini 2.2 model, and along with that, I have used a pretty used RAG database, which I have built myself. It is basically RAG database is a set of examples. So when an AI is told to generate any command, it will go to the RAGDB. It will search if it can. It will check if it can generate the proper command using that RAGDB. If it can't generate the command using the RAGDB, it will generate the command itself by using its own computational power. Later, after generation of the command, this work is done in backend.py. Later, it will check for malicious patterns with RAGDB. So again, RAGDB is used. It will check if any kind of malicious command of shutting down or turning off the firewall is generated, and yeah, so this is done using the sanitizer.py. If yes, then it will say malicious command detected, and we will see such kind of command on our access gate. And if not, then it will display the proper command in the access gate, and you can later edit the command here if you want to, and then you have to send it. And after sending it, when you click send here, it will compare the hash code with its IP pair in the SQL table, and then it will send the command, the whatever command you have written here, to that IP address. And after that sending of that IP address, it is actually an encrypted process. I have used TLS encryption using RSA keys. So when the command is sent to the listener runs that command and it sends the output back with the same kind of encryption. And later, when I receive that command on the host, it will be again re-explained by AI. That is, this work is done by explainer.py, and the display is like finally we can see that the explained output is displayed on the access gate.